This video will focus on two learning targets, mostly because they really go together. I can match the different laws to the different scientists that developed them. So we'll talk about three different scientists. And then I can interpret the relationship between pressure, volume, and temperature when one variable is being held constant. So this video will cover the three main gas laws: Boyle's law, Charles' law, and Gay-Lussac's law. Each law includes two out of these three variables changing and the relationship that is established between the two of them. So Boyle's law is our first law, and for Boyle's law, it's a pressure-volume relationship when temperature is not changing. So if you have a sample of gas and you hold the temperature constant, if you change pressure, volume changes, and they change inversely to one another. So if you have a sample of gas, say like a balloon, and you decrease the volume, make it go smaller, you increase the pressure. Those two variables are inversely related every time you do them. On the screen here, you see the mathematical relationship in words and then also as an equation. So essentially, some variable P times V is a constant because if you change one, you change the other, proportional to one another. So for these laws, we usually mathematically look at them over changing time. So if I have some initial pressure-volume relationship and then change one of the variables, the other one will change to keep the two sets proportional. So P1V1 equals P2V2. What that means is some initial pressure and some initial volume multiplied together are going to equal the new conditions, pressure and volume multiplied. So those relationships are proportional. Biggest thing about these equations then is that on both sides, pressure have to have the same label. It doesn't matter if you're measuring them in kPa or ATM or mmHg, they have to be the same. And then same with volume. It can be in liters or mils as long as volume 1 and volume 2 are measured in the same thing. So to have a proportional relationship, all the variables have to have the same label, and then they're just equal to one another. Graphically, if you think about an inverse relationship, what that means for Boyle's law is we'll have this nice little curve. So as one goes down, one goes up. This is what an inverse relationship looks like. We'll do an experiment with this in class so that you can see this graph get generated, but you should know that they're inversely related, creates some kind of graphical relationship like this. The next law is Charles' law, and for this law, now pressure is being held constant. It's not being allowed to change. And now if you change the volume of the gas, you change the temperature of the gas. Or really my brain more thinks of it the other way. If you change the temperature of the gas, you change the volume of the gas. So these now are directly proportional rather than inversely. So for Charles' law, they're directly. If you increase the temperature of the gas without allowing the pressure to change, you're going to increase the volume that those gases take up. Vice versa, if you decrease temperature, you're going to decrease the volume because pressure is being held constant. So biggest thing in order to understand kind of what's happening is to remember that that one variable is not being allowed to change. So if we're decreasing the temperature of a gas, making them move less quickly, essentially if we want the pressure to stay constant, same force applied per area, you need the volume to decrease to keep all of those variables related. Now, same as Boyle's law, we set these two things equal to each other, essentially initial condition, final condition, those are both proportional. But in terms of labels, again, you can have volume in mils or liters, but temperature has to be in Kelvin. And that's because if you do Celsius, you have the negative sign that might totally mess up your math. You could end up calculating like a negative volume if you have a negative temperature. So for Charles' law and for most of the gas laws, you want to do Kelvin, or you want to do temperature in Kelvin in order to make it so the negative isn't going to mess up your calculations. Charles' law is a direct relationship. As one goes up, the other goes up. So you can see this nice linear relationship between the volume and the temperature. The last law is Gay-Lussac's law. And now for this one, you're holding the volume constant and just allowing the pressure and temperature to change. And what happens here is they are also directly related. So if I increase the temperature without allowing the volume to change at all, I'm going to increase my pressure, more force over that area. And then vice versa, if I decrease, I'm going to decrease, again, because I'm not allowing the volume to change. So this law is very similar to Charles' law. Pressure can be in whatever variable or whatever label as long as it's the same, and the temperature has to be in Kelvin once again. Graphically, again, because it's the same, there is a linear relationship. What we do with these then is math. So this is what math can look like. I'll do another little video on how the math works. Let's go ahead and do the quiz and have a nice night.